Hey everyone, what is happening? Hope you're enjoying your spring break so far, and today we're going to be talking a little bit about factors affecting the rate of chemical reactions. Now, we touched on this on the last day of school before spring break, but I just want to have a little refresher, so if you did miss that day, you can watch this and get right up to speed, if you will. Now, factors affecting the rate, well, rate is speed. And that's the speed of chemical reactions. Now, they can either happen very quickly or they can happen very slowly. An example of a fast reaction would be an explosion occurring when a spark hits gasoline. A slow reaction that takes a long time would be a bicycle chain rusting over a period of years. Now, in a chemical reaction, how fast reactants turn into products is called the reaction rate. A reaction that takes a long time to happen has a low reaction rate, and a reaction that happens quickly has a high reaction rate. Now, every chemical reaction has a specific time that it takes, but there's things that we can do to speed up or slow things down, and really we're going to manipulate things. So the first thing we can do is manipulate the temperature of the reaction. So the temperature of a reaction affects how fast it happens. If you increase the temperature at which a reaction is taking place, the reaction will happen faster. And if you decrease the temperature at which a reaction is taking place, the reaction will happen slower. That makes sense. Now, this happens because increasing the temperature of a reaction increases the particle's ability to move more quickly, which increases the chances they will collide and react with each other. Now, you really want to think about this. This is my example for this is I want you to think about Kraft dinner. What we have is you're not going to just put your Kraft dinner in warm water. You're going to boil that. And what it does is it increases the rate of that reaction. It only takes 3 or 4 minutes. If we were to let it sit in freezing cold water, it might take hours for the pasta to soften up. Number 2, concentration. Concentration refers to how much of a solute. Now, a solute is a special name for a solid dissolved in water. All right, so concentration refers to how much of a solute is dissolved in a solution. We usually measure concentration by knowing what mass of a substance is dissolved in 1 liter of a solution. Now, in order for a reaction to happen, reactant and product molecules must be able to meet with each other and collide. Now, if the concentration of the particles is higher, there's a greater chance of meeting this. And right now, I want you to think of making iced tea. You know it tastes good when you got the concentration just right, but if it's too weak, it won't taste right and you'll add a little bit more. And if it tastes too sweet, you'll probably add some more water to make it more dilute. Now, if concentration is increased, the reaction rate is higher. Now, if the concentration is decreased, the reaction rate is lower. So we're talking about speed there. So for example, if we have hydrochloric acid and we mix it with zinc metal to produce hydrogen gas in the following reaction, we get, so if a dilute concentration of hydrochloric acid is used, the bubbles of the hydrogen gas are formed very slowly. But if a high concentration of HCl is used, the bubbles can be seen and they form more quickly. All right. And now we remember if we've got an acid plus a metal, we get a salt plus hydrogen gas. A third way that we can look at or increase or manipulate how fast or slow a reaction takes place is we can manipulate the surface area. Now, surface area is a measure of how much area of an object is exposed. The more surface area an object has, the faster it will react because more of its particles are exposed. Let's think about a sugar cube. So if we've got a sugar cube right there, you put a sugar cube in warm coffee or hot coffee, and what it does, it takes a little bit of time to disintegrate, to dissolve. Now, if we just have a spoonful of sugar, that's going to take way less time to dissolve in your coffee, therefore it'll happen faster. Now, another example for this is when people start a campfire. We don't just throw a big log on and hope that it lights, we usually use kindling or wood shavings to start out rather than a big log. In fact, sawdust can be really dangerous in places like sawmills and stuff. This is because the wood cut up into tiny pieces has much more surface area than a wood in a big chunk. So a higher surface area means a faster reaction rate, and a lower surface area means a slower reaction rate. Now, surface area is also important between two liquids that can not mix together. So I want you to think about oil and water. And if we have a big beaker like this and then a small beaker like this, and what we're going to do is we've got our water on the bottom and we're going to have oil on the top. And you can see that there's a lot more surface area between the water and the oil compared to over here. All right, so the greater the area where they are able to touch, the more particles we'll be able to meet and the reaction will happen faster. All right, have a good rest of the day. Talk to you soon.